Today out there, this very day, we want to look at algebra of vectors, solving few examples on vectors, that is finding resultants of vectors. We're going to be doing that with some vector diagram questions. So let's take a look at this very one. The first one that we have here, it says ABC is a triangle, AC equals A, and vector AB equals B. Find in terms of A and B, the vector CB and the vector BC. All right, right in the diagram we have here, we have the vector AB. The vector AB is given to us, so that's B. We have the vector AC that is also given to us, that is A. So we are asked to find the vector CB. The vector CB is that vector which has a start point at C and end point at B. That means if we talk about vector CB, then the arrow will be directed towards B. So the vector CB is the movement that takes me from the point C to the point B. So how can I get that resultant from the other length or from the other vector that makes up this diagram? That will be moving from C to B. So moving from C to B will be exactly the same thing as moving from C first to A and from A then to B. So it means that my vector CB is going to be vector CA plus vector AB. Do not forget, we are not given vector CA, rather we are given vector AC. We are not given vector CA, we are given vector AC. But vector CA is definitely the negative of vector AC. We are not given we are given vector AB. Okay, that's clearly seen right there. So let's get on to our solution. So the solution for the first one, we have the vector CB is vector CA plus vector AB. That is, the vector CB is simply the movement from C to A and then from A to B. Vector CA, like I said earlier, is the negative of vector AC, that is minus A, and the vector AB is given, that is B. So the solution to that is minus A plus B. Now for the second part of it, we are asked to find the vector BC. The vector BC means the vector that runs from B, or start point is B, and the end point is C. In other words, this is this is going to be the same thing as moving from the point B to A, and then from point A to C. From point B to A, then from point A to C. That is vector BA plus vector AC. That is vector BA plus vector AC. Vector BA is not given, rather we are given vector AB. So vector AB is B, therefore vector BA is going to be the negative of AB. So that's why we have minus B. Then meanwhile, the vector AC is given to us. Vector AC, you can see right there in the diagram. It is given, that's A. So we have vector BC to be the same thing as vector BA, which is minus B, plus vector AC, that's plus A. So that gives us minus B plus A, or A minus B. Now let's take another example. This one says that JKL is a triangle. JL equals A and LK equals C. We are also told that JK is equals KX. JK, the length of JK, or the vector JK, is going to be the vector KX. The length, or JK, is the same thing as KX. So if we can find the vector JK, we automatically have found the vector KS. So let's start with the first one that says to find the vector JK. The vector JK is going to be the vector JL plus the vector LK. J to K means moving from J first to L and then from L to K. Now let's start from J. J to L, that's JL is given to us as A. You can see the arrow pointed at L. So JL is given. LK is also given as C. So our simple solution here becomes A plus C. Now let's move on to the next, which is JX. Jx is the length from J to X. We have already found Jk. Jk having been found, then we multiply Jk by 2 to get Jx. Or you go writing Jk plus Jk equals Jx. So 2 times Jk, that gives us 2 times Jk. Of course, that's going to be 2 times A plus C. Now, lastly, we have to find the vector L. As, that's going to be, oh, sorry, this is an error. That's going to be 2A plus C. All right, that's same thing as 2A plus 2C. Now, the vector Lx, we have to find the vector Lx. The vector Lx, that's from here, L down to X, right there. All right, that is the vector we are asked to find. The vector Lx is, the vector start point is L and the end point is X. Of course, that will be the same thing as the movement from L to J and then J down to X. You can also see it's the same thing as L to K and then K to X. Whichever way you get your problem solved, you arrive at the same answer. So see how I have solved mine. A vector Lx vector Lx is going to be vector Lk plus vector Kx. So I've chosen to solve as Lk plus Ks. That is, I've chosen to take this part L to K and then K to X. Now, what is my L to K? L to K is obviously given. That's this arrow. That would be C. And then my Kx. Remember, my Kx is the same thing as my Jk. So that would be A plus C. When I open that bracket, of course, that will give me A plus 2C. That solves the problem for this particular example. Now let us see this next one. This is just an alternative way of solving that particular um, the third one that I just solved right now. So this is an alternative solution. You arrive at the same answer. All right, now the question here says find the following vectors in terms of find the following vectors in terms of A and B. All right, I'll just go answer all of it right away. The answer to all of that right away. But let's see how we arrive at all these answers one after the other. The vector the vector SR, we are asked to find the vector RS is given. So the vector SR is going to be minus or negative of vector RS. The vector SR is from S to R. That's in opposite direction to RS. RS is A, SR is in the opposite direction. That would be minus A. So that answers this. Then we have to find the vector QP, Q to P. We are not given Q to P, we are rather given P to Q. The vector PQ is 2A, so therefore the vector QP will be negative of vector PQ. That's going to give us minus 2A. The vector QS, the vector QS is also not given, rather we're given the vector SQ. So the vector QS is going to be the negative of vector SQ, that's going to be minus P. And then we have to find the vector RP, the vector RP, meaning movement from R to P. So that will be the same thing as R to S, S to Q, Q to P. R to S is given, S to Q is given, Q to P is not, but that is definitely the negative of vector P to Q. So our solution runs this way, RS plus SQ plus QP. But QP is negative of PQ, so that RP becomes A for RS and B for SQ, and then minus 2A for QP. Of course, the final answer to that, when it's simplified, that's going to be B minus A. All right, one more example we have to solve, and that will be all. DEF is a triangle. DF equals A, DE equals B. Y is the point on EF. Y is the point on EF such that EY ratio YF is 2:1. Find in terms of A and B, EF, EY, and GY. Now, the first one, EF, is a journey that starts from E and ends at F. That means our arrow is directed towards F. So if we're going to talk about EF, then that should be the same as the movement from E to D and then D to F. Now, ED is not given, but definitely is the opposite to DE, which is given as B. So ED is going to be minus B, then DF is going to be A. So let's see our solution plays out. So EF is going to be ED plus DF, and ED is going to be the same as the negative of DE, which is given to us. The negative of DE is given to us, so that's going to be minus B plus A. Minus B plus A. You can pause the video and get a quick look at the workings. So that gives us the answer to that. Now the second part says we should find, second part talks about finding the vector EY. Now EY is not given. EY is not given. Of course, we have to find EY. Take note that we are given the ratio EY to YF as 2:1. This is something as saying EY over YF is 2:1 or 2/1. It is the same thing as saying that EY is going to be equal to 2 over EY over YF is going to be 2/1. If you cross multiplying that, of course, you're going to get that one is going to be 2 times of the other. Now, the way to attempt this problem is to first find the total ratio. The total ratio will be 2 plus 1. That's going to be 3. Now, the EY is going to be 2 parts out of the total ratio times the full length or the full vector EF. I'll come again. EY has a ratio of 2 out of 3. The total ratio for this is 3, so that's why you have 3 down there. Then the part that represents EY is 2, so we have 2 out of a total of 3, multiplied by the full vector or the full length EF. Of course, it's not a length, it's a vector. It is not a length, it's a vector. The vector EF has already been calculated, so that means we're going to be having 2 over 3 we're going to be having 2 over 3 of A minus B. Remember we calculated vector EF earlier as A minus B. Now there's the last part of this that we have to solve. That is the vector dy. The vector dy. Right, the vector dy is a vector that runs vector dy is the vector that runs from the point D down to Y. The vector that runs from the point D, or whose start point is D, and the end point is Y. I'm going to do that again. All right, so that's D to Y. All right, so that's the vector dy. Now the vector dy will be the vector whose start point is d and ends at y. So that will be the same movement as d to e and then e to y. We have found ey and we know d to e. We know d to e. The vector dy could also be taken as the vector df plus fy. But it really makes no sense going about df then fy to find vector dy because fy I have not found actually. Of course, it can be found, but it is easier going the way for which I already have found some part of it. I have found this point is E. I found EY already, and DE is also given. So DY will be my DE plus my EY. Now my DE is actually given as B, so that's vector B, as B right here, plus my vector EY. My vector EY is going to be 2 over 3 of A minus B. Now, if I go on to simplify that, opening the bracket, I have 2 over 3a minus 2 over 3b. Working out this b minus 2 over 3b, that would be 1 over 3b. And then that would be 1 over 3b plus 2 over 3a. 1 over 3 can be brought out or simplified out. That would be 1 over 3b plus a. That gives me the vector dy. When you are given a problem that involves ratio, all you need to do is to try and find the total ratio and see how that helps to solve the problem. Of course, that's not the only way you can get the problem solved, but you can start from there. It is simpler doing the total ratio workings if it is a kind of problem that is similar to this which I have addressed right now.